Today we are talking about matter, and our catchy title page today is What's the Matter? This is an introduction to chemistry. Matter is the stuff that things are made of. Okay, so if we're going to talk about living things, we first have to talk about the essential components of all things. Okay, what are the essential components of all things? And the essential component of all things is matter. Matter, we talked about this when we were doing the biogeochemical cycles. We talked about matter. And we said, back then, that matter is something that has mass and takes up space. Something that has mass and takes up space. Okay, so for a minute, if you take a minute now and jot down some things that are matter. Okay, a desk, your desk is matter. You have mass and you take up space. It's a little bit more fun exercise to think about things that might not be matter. Question. Is air matter? Does air have mass and take up space? Well, we can do a thought experiment with this, since I can't show you on video something about this. We'll do it in class. We'll prove this in class. But just think about if you took a balloon, and you blew it up. What are you putting in the balloon? You're putting air in the balloon. So air takes up space. And you sit here in your room or in the classroom and you look around and you're like, well, it doesn't feel like air is taking up any space. And that's because air has always been there. And to us, air doesn't have any mass. But we measure something called air pressure. They talk about it on the weather reports in the morning. They call it barometric pressure, or there's a low pressure, a high pressure, and that's measuring air pressure. And if air can put pressure on you, then air must have mass. And we'll talk about some of that stuff in class too. We'll also look at some other things that may or may not be matter. An atom, which you may have heard of, is the smallest unit of matter. Atoms are the smallest unit of matter, although that's arguable, and we can talk about the fact that there are smaller things yet. Atoms contain things called electrons, things called neutrons, and things called protons. Electrons have a negative charge, neutrons have a neutral charge, and protons have a positive charge. This should be basic 7th grade, 6th grade, 7th grade, 8th grade science that we're dealing with right now. Protons and neutrons, P and N, are found in the nucleus. The nucleus of an atom. Do not confuse that with the nucleus of a cell. Very different things. Nucleus of an atom. Electrons are found orbiting around the outside of the nucleus. Electrons are found orbiting outside of the nucleus. Electrons are zinging around outside of the nucleus, and we'll talk about that in a little more detail in a minute. Now, to understand the scale that we're talking about, atoms are extraordinarily small to us. If this right here, this circle I've drawn on the screen, was the nucleus of an atom, and we went to find the nearest electron, and so we're standing here, and this is truly the size, about the size of your fist, of a nucleus. How far would we have to walk to run into the first electron? The answer to that is from my classroom or the school to McDonald's. That from here to the first electron, if this were truly the size of the atom, would be about 1.5 miles. Another way to think about it is if you've ever been in a giant college football stadium, like the best one in the world, the University of Michigan's football stadium. If you put an orange or on the 50-yard line, an orange, that the whole size of the atom is still a little bit bigger than that football stadium, with the nucleus being the orange on the 50-yard line. Elements are things, I don't know why this word isn't in here, matter made up of the same kind of atom. Elements are matter made up of the same kind of atom. Elements are defined by the number of protons in every atom of the substance. The number of protons in every atom of the substance defines the element. Elements are arranged in something called a periodic table. Now we're going to come back to all this when we talk about atoms. Elements are arranged in something called a periodic table. Here is an element. I've shown you an element. I don't know if any of you know what element is in this sign. The element is a gas called neon. Every atom in this neon gas has 10 protons. Every atom in neon gas has 10 protons. That's what makes it neon. Okay, that's what makes it neon. You'll have to know how to do this. This is a box. I'm going to click ahead and come back. Just a minute. Here is what we call the periodic table of the elements. The elements, hydrogen, helium. Here's neon right here, over on the far right. So I just circled it. Okay. They have these fancy letter symbols, okay, that sometimes go with what they are and sometimes don't. For example, CO, right here, number 27 is cobalt. Ni is nickel. But Fe is iron. Okay? So they have symbols that sometimes help you figure out what they are and sometimes don't. All right, let's go back. Here is a box on the periodic table. I'm going to put this all on the screen. The top number of the box, in the box, refers to the number of protons in the atom, called the atomic number. Now that number on the periodic table on the next slide is up here in the corner, but it doesn't matter, somewhere near the top, which happens to also equal the number of electrons, and we'll come back to that. Chemical symbol, Li, is for lithium. Li is the chemical symbol, and then the chemical name is generally, not always, shown on the periodic table. The one I just showed you didn't have it. And then at the bottom, usually at the bottom, sometimes in the upper right-hand corner, up here, is a number that is not usually even. It's usually a decimal number, and or not usually a whole number, not usually it's usually a decimal number, and it is called the atomic mass. The average atomic mass. The atomic mass tells you the number of protons in lithium and the number of neutrons. It's the number of protons plus the number of neutrons. The mass of an atom, how much it weighs, is defined by its protons and neutrons. And you might be like, well, what about electrons? Why aren't electrons used? Well, because electrons are so small. They are so small that they really weigh nothing compared to the whole atom. This atom, lithium, has 3 protons and 3 electrons. I'm just writing them as positive and negative. The 3 protons weigh 3. That 3 number, these are called atomic mass units, or AMUs. 3 AMUs is the number of protons. So, in this atom of lithium, there are 3 protons in every atom, plus the number of neutrons, equals, we'll round this number, we round that number to 7. So how many neutrons are in lithium? Well, 3 plus blank equals 7. Do the math, do the algebra, subtract 3 from each side, neutrons equals 4. Number of neutrons equals 4. So there are 4 neutrons in a normal atom of lithium. There are also 3 electrons. This number, the protons and neutrons have to balance out because we need 0 as a charge. Well, why don't electrons count? Because they're 2,000 times smaller than a proton. So 3 electrons are adding almost nothing to the mass, so we don't count them. So if we go to our periodic table here, we pick an atom like number 12, magnesium. Number of protons equals 12. How do I know? Right there. Number of electrons equals 12. How do I know? Right there. Number of the atomic mass tells us protons plus neutrons equals 24. Well, we already know from up there that there are 12 protons. So that must mean that there are 12 neutrons to get to 24. And you can do that for any of those numbers in the chart. Next term, compounds. Much of the matter we run into every day is a combination of elements. It's not just an element. For example, the plastic chair you're sitting on, if you're sitting on a plastic chair in the classroom or if you're sitting on a chair at home, is made of a combination of elements. Plastic is not an element. It's a compound. It's a combination of 2 or more elements. A couple examples. H2O. H2O, what is it? I hope you know by now that H2O is water. That's a compound. It's made of 2 hydrogen atoms bonded to 1 oxygen atom. This is called, right here, a molecule of water. Here in this ocean, there are jillions of molecules of water. If we take a sodium atom and combine it with a chlorine atom, we get sodium chloride, aka salt. If this is the ocean, there is salt dissolved in this water. Okay? That's a compound. 2 or more elements chemically combined. There are 2 ways that we can put elements together. There are 2 ways we can put elements together because this is a combination. There's covalent and ionic, and let's talk about those. In a covalent bond, electrons are shared. In a covalent bond, electrons are shared. In an ionic bond, electrons are transferred. And it's kind of beyond the scope of this lecture to talk about why. We'll do that in class, actually. I'll take some time in class to go into detail about why that is. And if you're absent this day and you're watching this because you're absent, you need to stop in and talk to me about that.